Let's take a look at a radical equation that's a little bit more complicated. Radical x plus 3 equals 3. Now, the reason this is a little bit more complicated, and it's different than ones we've seen before, is that there's two radicals. So normally my goal is to isolate the radical. But in this case, I can't isolate it because there's two of them. So what I'm going to do is I'm going to put one radical on one side and one radical on the other. So I'm going to start by subtracting the square root of x. So on the left side, I'm going to have the square root of x plus 3. And on the right side, I'm going to have 3 minus the square root of x. Now, I'm going to square both sides. So on the left side, my square root and my squared cancel, and I'm left with x plus 3. But on the right side, I have 3 minus the square root of x times 3 minus the square root of x. So I'm going to show the box method on the side, but you could, of course, double distribute if you want. So I have 3 minus radical x, 3 minus radical x. So 3 times 3 gives me 9. 3 times minus radical x is negative 3 radical x, which is the same thing up in this corner. And then negative times a negative is a positive, and radical x times radical x is x. So if I combine my like terms, I have 9 plus x minus 6 radical x. So I'm going to put that back on the right-hand side of my equation. And then I'm just going to bring down my left-hand side. So now I still have a radical. So I want to isolate that radical. So the first thing I'm going to do is I'm going to subtract 9 on both sides. So I have x minus 6 equals x minus 6 radical x. Still want to isolate that radical, so I'm going to subtract x on both sides. So my x's are actually going to cancel on both sides. And now I have a negative 6 equals negative 6 radical x. So this negative 6 radical x on the right-hand side is attached by multiplication. So the opposite is division. So when I divide both sides by negative 6, I'm going to get radical x equals 1. So now remember, my radicals alone, I'm going to square both sides. So 1 equals x. But remember, it's a radical, so you always want to check your solutions. So remember, you have 3 ways to check your solutions. Substitute in, type the left side and the right side into y1 and y2 on the calculator, and then check either your point of intersection on the graph or your table. So I'll use the calculator for this one. So in my calculator, in y1, I'm going to type in the left side. Radical x, hit the right arrow to get outside, plus radical x plus 3. And then on the right side of the equation was 3, so I'm going to put that in y2. And now I can go to my table, so second graph. When x equals 1, are my y values the same? And they are. If you take a look, when x equals 1, y equals 3 in both y1 and y2. So that means my solution works. So I can scroll all the way back down. So my answer is 1. So same process, but a few more steps because you have to square a binomial that contains a radical.